Now take down a problem based on capacitor. In a parallel plate capacitor, with air between the plates, comma, each plate has an area of 6 into 10 to the power minus 3 meters square. 6 into 10 to the power minus 3 meters square. Minus 3 meter square. And the distance between the plates is 3 mm. Distance between the plates is 3 mm. Calculate the capacitance of the capacitor. Calculate the capacitance of the capacitor. Calculate the capacitance of the capacitor. If this capacitor is connected to a 100 volt supply, if this capacitor is connected to a 100 volt supply, what is the charge on each plate of the capacitor? What is the charge on each plate of the capacitor? Read once. In a parallel plate capacitor with air between the plates, each plate has an area of 6 into 10 to the power minus 3 meters square, and the distance between the plates is 3 mm. Calculate the capacitance of the capacitor. If this capacitor is connected to a 100 volt supply, what is the charge on each plate of the capacitor? So given, what are the given quantities? Given area of the plate A. Given area of the plate A is 6 into 10 to the power minus 3 meter square. Also given distance between the plates is 3 mm. And voltage across the capacitor is 100 volt. First, to calculate capacitance. C is epsilon naught A by T. The value of epsilon naught, you know, 8.854 into 10 to the power minus 12. .854 into 10 to the power minus 12 into area is 6 into minus 3. D is 3 mm. Convert it into meter. 10 to the power minus 3. Do the calculation. So it comes around 17.7 into 10 to the power minus 12. Because 10 to the power minus 3 will get cancelled, and 3 2s are 6. So 8.854 into 2 is 2 8s are 16. So 1 carry over, so you'll get 17.7. Or C is 17.7 picofarad. Next is asking, when a 100 volt supply is connected, what is the charge on each plate of the capacitor? So Q is Cv. Charge on, we know C is Q by V. So Q is equal to Cv, charge on each plate of the capacitor. Charge on each plate of the capacitor. Q is C into V. 17.7 into 10 to the power minus 12 multiplied by 100. So this is 10 square, 10 to the power minus 12. So that will give you 10 to the power minus 10, or it is 1.77 into 10 to the power minus 9 coulomb. So why did I write like this? This is 1.77 nano coulomb. Or you can write 17.7 into 10 to the power minus 10. Write the unit properly. That completes that one problem. Next we will see another one. Take down this. What is the area of the plates of a, what is the area of the plates of a 2 farad parallel plate capacitor? Given that the separation between the plates is 0.5 centimeter. What is the area of the plates of a 2 farad parallel plate capacitor, given that the separation between the plates is 0.5 centimeter? Here we are given with the value of C. Given C is 2 farad and the separation between the plates is 0.5 centimeter. He is asking what is area. We have C is epsilon naught A by D. From this, A is CD by epsilon naught. C is 2 farad. D is 0.5 centimeter. Convert it into meter. Divided by 8.854 into 10 to the power minus 12. Calculate, so it comes to, so here 10 to the power minus 2 minus 12, that will become 10 to the power 10. Area A is equal to 1.13 into 10 to the power 9 meter square. Or it is You can write it in kilometer. 1.13 is there, so it is approximately 1130 kilometers square. This is such a big value, you know. So this one, if you see, 1.13 into 10 to the power 9. So such a big value. So this is why actually, you know, the ordinary capacitors are in the range of microfarad or less. So we do not use capacitor in the range of farad because the area of the plate should be very high it comes. So the ordinary capacitors are, you know, rated in microfarad, picofarad or nanofarad. Otherwise it is too high.